Welcome everybody to video number 25. This one's going to be all about atomic structure. Atoms are the smallest piece of matter. That's a good definition to start with. And when we say smallest piece of matter, we mean the ones that still have physical and chemical properties. Physical properties are like color and texture, luster, ductile, malleable, all those kinds of things. And chemical properties I taught you too, and that was reactivity and flammability. So atoms are the smallest piece of matter that still have both physical and chemical properties. Now, can you, and what happens if you break up an atom? Well, absolutely you can break up an atom. And what happens if you do, it's kind of like just taking a bunch of car parts or parts to a paper doll here. They're just bits and pieces. They no longer have any physical or chemical properties. They're just parts. So it could be just an engine, if you're talking about a car or a door or something like that. But when you get back to atoms, I wanted to show you, and we're going to use an awful lot of models when we're talking about atoms and elements. Atoms are made up of two main parts, and the nucleus is going to be found in the middle of the atom, and that's going to be represented by that red circle there. Now you may want to think back and go, well, that sounds like a nucleus and a cell, and you would be right, meaning that they're both in the middle of the both atom and a cell. Now the electron cloud actually surrounds the nucleus, and that's where you see those rings and those green and purple ones running around it. That's the electron cloud, and it surrounds the nucleus. So these are your two main parts of an atom, and I'll show you who lives there and what they do. Nucleuses have two guys that live there, and I call them housemates. These are your protons and your neutrons. Protons have a positive charge, and they're represented by a P and a plus sign, so those are easy to remember. And then you have neutrons, which are neutral or no charge, meaning they're not positive and they're not negative, so we just represent them by an N. So here are your two housemates, protons and neutrons, that live in your nucleus. Now your electron cloud is where you're going to actually have a lot of volume, and this is where your electrons live. They surround the nucleus, and it's showing you, it's going around, it's going ping, ping, ping. Think of it as like little third graders out on recess, running around, right? You're going to see words here that you're going to go, whoa, those are big fancy terms. Don't be worried about them. When you see things that are called subatomic particles, basically it just means the three things that make up an atom, and we've already talked about all three, but what I wanted to do is I wanted to show you them side by side so that you could get a good comparison between them. Every atom has these. So we'll start with the protons. Remember, they live in the nucleus. They're a positive charge, and they're represented by a P+. Then you have the neutrons, right? They're the other housemate that lives in the nucleus. They have no charge, and we represent them with an N. And then you're going to have your electrons. They live in your electron cloud. Remember, those are the ones that are running all around, and those are represented by an E and a negative sign. I wanted to compare a nucleus and electron cloud for you, kind of like when we did with solid, liquid, gas, when we were talking about definite shape and volume. So the nucleus is going to have the most mass, and remember, that's the red circle there in the middle. And remember, our two housemates live there, our protons and our neutrons. Now the electron cloud is actually going to have the most volume. It's actually going to take up the most space, and that's going to contain your electrons, and those are the purple and the green ones you see there. Let's talk about size comparison. So when you're talking about your three subatomic particles, so your protons and neutrons and electrons, let's talk about size. And I'm also noticing that this whoopsie says nucleus, and it should say neutron. So a proton and a neutron are the exact same size, so we like to think of them as a 1-to-1 ratio, and the electrons are actually super teeny weeny small, and it would actually take 2,000 electrons to actually equal the size of a proton or a neutron. So they're itty bitty. Now we're going to talk about atomic models, and I'll draw and label these with you here at the end in a second. Atomic models, and I didn't make this up, this is a real one. There are fried egg models, and this is where the yolk in the middle is going to have the most, and that should say mass there, sorry, and that's the nucleus, and then the white is the electron cloud, and that's going to take up the most volume. So just like you would if you're frying an egg at home, or maybe that's what you guys had for breakfast this morning, you can say, hey, that's a great atomic model, and you can teach your parents about it. I wanted to give you, I like to give you guys options, and I wanted to show you a little bit more complex atomic model, so I'm going to show you a Bohr model here. And Bohr model's named after an old dead dude, Niels Bohr, and I'll do a whole video about him, and we'll do a whole lab, and you guys will get really good at drawing these. And what it is it's a little bit more complex than the fried egg model, because if you notice right off the bat here, it does show the nucleus in the middle similar, but then you have what looks like these circles or these rings or these levels. And the Bohr model will actually show you where each of those individual electrons live, and you can actually learn the rules, and I'll show you the placements on how to do that.